All right, in this video, we're going to kind of go over some vocabulary type things, just so when we say words, we want to make sure that we mean the same things by them. So remember, we've talked about the fact that when you want to answer a question, you're probably going to do some kind of a study. All right, and the population are all the items that you're investigating. And usually you're going to grab a subset or a sample of those and study that. And if your subset's valid, and there's another video about types of sampling, then what you want to do is hopefully you can generalize from your study from the sample back up to the population. All right, and the data is the information that you're gathering from your study, whether it's an experimental study or an observational study. Let me share a PowerPoint with you and just kind of talk you through some vocabulary words, okay, that you're going to hear kind of throughout the semester. All right, you need to know the difference between a parameter and a statistic. All right, both of them are numerical measurements. In other words, both of them are numbers. The difference is where the number comes from. So a parameter would be a number that comes from a population, from the big set. And a statistic is a number that comes from a subset of that from a sample. So if I said the average age, maybe I wanted to know the average age of a college student. Okay. So suppose the average age of a college student is 21 and 2/10 years. Well, where did I get that number? Did I get it from all the students in all the colleges around the world? If I got data from all the colleges in all the the post-secondary schools in the whole world, that's probably not practical. But if I did, and that average was 21 and 2/10, that'd be a parameter number. More than likely, though, I would have done a study and gotten a sample from several places and give you a statistic. So it matters whether it's a parameter or statistic. So you're going to see statistics more often than you're going to see parameters. Another thing that's going to happen, though, toward the end of the course, we are going to do studies and get statistics and then generalize those back up to parameters. So in order to distinguish between the two, toward the end of the semester, you'll notice that parameters tend to be used, they use Greek letters, all right, like mu, or, alpha, or, sigma. So a lot of times statistics use English letters. So that's a quick way when you're reading a study. If you see a Greek letter, it's probably a parameter. If you see an English letter, we'll talk about it later, it's probably going to be a statistic. But we'll kind of get into that a little bit more as we go. Okay, now, two types of data that you have are qualitative and quantitative. Now, qualitative data is remember, non means not. Non-numerical means not numbers. So they're not numbers. So usually they're words. So qualitative data might be, what color car do you drive? Or what color hair do you have? Or what gender are you? Or what's your place of birth? All right. So a lot of times qualitative data are words, and a lot of word data is very important. Now, when I say non-numerical, then I mean not numbers. There is a qualifier here, though. It can be a number if that number is not really used as a number. In other words, if that number is really for identification only, like a jersey number. Like if you're playing basketball and you're number 15, that doesn't mean that you're better or worse or older or younger or taller or shorter than number 14. It's just a number on your jersey for identification, like foul on number 15, instead of saying foul on Jones. Okay. Now, there are a lot of numbers that are kind of qualitative data. Think about a number here at MC that's used all the time just to identify you. That's right, your student ID number. Your 700 number is really just in place of a name. If your number is one higher than somebody else's, that doesn't even mean that you came in before them or that you're alphabetically, it means nothing. All right. So most of the time it's words, but it can be a number if the number is only for identification. Quantitative data is numerical data. So they are numbers that act like numbers. All right. So your ACT score, 20 is obviously a better score than a 19. Neither one of those are as good as a 28. Okay. Your weight, you can put those in an order, you know, those make sense, your age. So there are lots of numbers that we use, blood pressure, pulse rates, you know, all kind of grades in a class. So word data, qualitative, numbers data is quantitative, like quantity. That's the root word for quantitative data. Now, if your data is quantitative, if your data is numbers, they'll subdivide that. Some quantitative data is what we call discrete, and some is called continuous. Now, discrete data has a finite number of possibilities, okay? Or they say it's countable. Now, this is Gann's little phrase down here that sometimes helps. Here's the way I tell students, sometimes it's easier to look at the measuring scale. If the measuring scale has gaps in it, it's discrete data. Now, what do I mean by that? My example is shoe size. Think about shoe sizes. If you had to, you could write down every single shoe size that exists, starting with 0, 0, a half, but think about shoe sizes. They go from 7 to 7.5 to 8 to 8.5 to 9. So they're gaps. I mean, if your foot's really like a 7 1/4, you can either squeeze your foot in a size 7 or flop around in a 7 1/2. There's not a 7 1/4 shoe size. So that's what I mean by there are gaps in the data. So it jumps from 7 to 7 1/2, from 7 1/2 to 8. So that's why discrete data is got gaps in that scale. Now, continuous data doesn't have any gaps. So remember, continuous, that's what continuous means. It's just, you know, goes on and on and on and on. So weight would be an example of continuous data. You don't weigh 120 and then jump to 121. Sometime you must have weighed 120.483. Okay. So, and when you get a more accurate scale, you get a more accurate number. Okay. So there's no way for me to write down every single exactly precise weight of a person. That's why weight is continuous data. So I give a silly example of this in my calculus class. Okay, there's a theorem in calculus that talks about this. And so the silly example I give them is this. Weight is continuous data. Okay, you don't go from 150 to 151, or you don't go from 150 to 160 without going through those numbers in between. So when I was pregnant with my first child, before I was pregnant with my first child, it seemed to be the consensus of the general population that I was too skinny. I didn't agree, but okay. By the time I was about 8 months pregnant, we could all agree I was too fat. So here's what I can mathematically prove. Because weight is continuous data, that means if there was a moment in time when I was too skinny, and there was a moment in time when I was too fat, there must have been a moment in time when I was perfect. Because you can't go from too skinny to too fat without going through perfect. Unfortunately, the theorem in calculus is an existence theorem, which just tells me that it existed, doesn't tell me when. But I can mathematically prove I was perfect weight-wise. Okay, so discrete data has gaps, continuous data does not. Now, they talk about levels of measurement in your book. All right, so they give you 4 levels of measurement. So I'm going to kind of go through them from least specific to most specific. All right, so nominal data, there's no order to it. Okay, it's just category only, like hair color. Blonde-haired people aren't better or worse, before, after, above or below, younger, older, anything than brunette-haired people. So your hair color, there's no order to it. Okay, your gender, you know, there's no order. Males are not higher, lower, above, below, before, after females. Okay, so if the data is nominal, that means there's just no order to it. All right, so the way that you would organize it and the way that somebody else would organize it could both be great ways of organizing it and be nothing the same. So no order with nominal data. And think about what nominal means. If I tell you something's nominally helpful, that means not very much. Okay, so nominal data is kind of your lowest level of measurement. Now, a little above nominal is ordinal. Now, the root word for ordinal is order. So obviously the data has order. So you can put the data in a logical order. The problem is, though, that the differences between them are either unknown or meaningless. Now, what do I mean by that? Notice the example I've given you on number 2 is star movie ratings. You know, when you go on like Rotten Tomatoes, or you go to a website and it says this movie is a 4-star and this movie is a 5-star. Well, now everybody knows that a 5-star movie is better than a 4-star movie. So you can put them in order from worst to best. Okay, so there's an order to those movie ratings. But you don't know how much better a 5-star movie is than a 4-star movie. Are all 5-star movies the same amount of better than 3-star movies? Not necessarily. Okay, and how do you get to be a 4-star instead of a 3-star? Do you know how? See, I don't. So those are unknown. So that's what I mean by ordinal. If you're in a race and somebody finishes first, second, and third, you know that first place was faster than second place, and second place was faster than third place. But the difference between first and second may not be the same time as the difference between second and third. First and second may have been really close, and then third's like 4 hours after that. Okay, so ordinals got an order, but the differences in them are unknown or meaningless. Now, the next 2, let's talk about them together because they tend to be the ones people get confused. Interval and ratio. Notice both of them also have order. All right, so you got ordinal and then you've got interval, and the top is ratio. Okay, so ordinal, interval, and ratio, all 3 have order. Okay, remember ordinal, though, the differences are unknown or meaningless. But with interval and ratio, with both of those, the differences are known and meaningful. So how do you distinguish between number 3 interval and number 4 ratio? It's whether the measuring scale has an absolute 0 or not. Now, what do I mean by that? Let's notice the examples I gave you. Number 3, the example is temperature in degrees Fahrenheit. Suppose I took all the state capitals in the United States, all 50, and I got their high temperature for August the 20th. If I gave you those 50 temperatures, could you put them in order? All right, so they're at least ordinal. All right, now, what about, you could put them low to high or high to low, it wouldn't matter, but they're in an order. So do you understand that if the high one place was 95 and the high one place was 94, they differ by 1 degree? Well, suppose the high over here is 80 and 81 in different capital. They differ by 1 degree. Does 1 degree over here mean the same thing as 1 degree over here? Yeah. So you understand the differences are known and meaningful. A degree here means the same thing as a degree over here. So that's why it goes from ordinal to interval. But why is it not ratio? Well, think about the scale. If you've got a Fahrenheit thermometer, is there a 0 on that thermometer? There is. But can you go below it? Yes. That's why I say absolute 0. Absolute 0 means there's a 0 and there's nothing below that. But think about it. In Bismarck, North Dakota in January, it may be a -7 degrees. So there's a 0 on that thermometer, but you can go below it, so it's not an absolute 0. So when it's 0 degrees outside, that's not the absence of all heat. That's why 40 degrees Fahrenheit is not twice as hot as 20 degrees Fahrenheit. Okay, so with interval, there may or may not be a 0, but if there's a 0 on the scale, you can go past it. That's not an absolute 0. But look at ratio. You can put them in order. The differences are known and meaningful. All right. And there's an absolute 0 on the scale. In other words, there's a 0 and you can't go past it. Think about a ruler. If I have a ruler or measuring tape and I want to measure your height, is there a 0 on that measuring tape? Yep. Can you go past it? No. Something can't be a -2 inches. So that's why 6 feet is twice as tall or twice as long as 3 feet, because there's an absolute zero. All right, weight would be another one. You can't weigh a negative amount. Okay. So do you understand the difference between interval and ratio? All right, so on your homework again, we're going to have some examples and they're going to ask you what level of measurement they are. So see if you can figure that out. Also on homework, they're going to ask you about, is this data qualitative or quantitative? They're going to ask you if things are discrete or continuous. They're going to ask you if this number is a parameter or statistic. Just look at where it came from. It came from a population. Notice parameter and population both start with P, and statistic and sample both start with S. So that's a handy dandy little memory trick. Okay. So try the homework. If you need some help, then just email me and let me know.